The graph of f on the closed interval -3 to 6 consists of 5 line segments, as shown in this figure. The function r is given as this polynomial, and it is known that we have these two definite integrals, the definite integral from -3 to -1 of r of x, and the integral from -3 to 4 of r of x. All right, we want to find the value of the integral from -3 to 5 of f of x. All right. Well, let's go ahead and do what we can with this. The integral from -3 to 5 of f of x, that is the area under the curve, or between the function and the x-axis of this function. So from -3 to 5, okay, we are looking at this area, and this area. And of course, the area underneath the x-axis is going to be negative, while the area above is positive. So let's go ahead and do that. This first area here is that's a triangle. So it's 1/2 base times height. That's 1/2 times the base is 2 times the height is 2, which is an area of 2. Okay. Down here we have a trapezoid, and the area of a trapezoid is 1/2 times the sum of the two parallel sides, which is that distance right there is 5, and that distance there is 3, so 5 plus 3. And then times the distance between the two parallel sides, which is 2. Which is 8. And then finally this area here, again 1/2 base times height, 1/2 1 times 2, which is 1. All right, so then this integral is 2, that's positive because it's above the axis, and then minus 8, since that's below the axis, and then plus 1, okay, which is -5. All right, part B, find the value of the integral from -1 to 4 of r of x. Well, we have two integrals here that involve r of x and that involve a -1 and a 4. So we'd like to combine these to get that. So the integral from -1 to 4 of r of x, we're going to split this up into the integrals that we know. So I have an integral that involves -1 and a -3 of r of x. And then I can pick back up from -3 and go till 4 of r of x. Okay, well, the integral from -1 to -3, you'll notice the bounds are flipped. That just makes this value negative. So this is -28.8. And then plus the integral from -3 to 4 is a -2.45. Okay, and then we can just combine these, and and that's negative 31.25. Okay. And so anytime you're given an integral, if you already know definite integrals, you want to look if there's some way that you can combine them to get what you are looking. Okay, part C, find the value of the integral from -1 to 4 of 1/5 r of x minus 2f of x. Well, I see the integral from -1 to 4. That's what we just did of r of x. So let's go ahead and split this. We have the integral from -1 to 4 of 1/5 r of x. So we'll bring the 1/5 and then the r of x. Okay, and then minus 2 integral from -1 to 4 of f of x. Now, this integral we just did. It's 1/5 times -31.25 minus 2 times this integral, -1 to 4 of f of x. Well, we don't have that yet, but we can get it. Okay, from -1 to 4, that's just this area down here. So I guess we do have it. Whoops. So this area down here, that integral is -8 because it's, of course, below the axis. And so times -8. Okay, I'm going to go ahead and just leave it in this form. All right, part D. Let h of x be this piecewise function, r of x if x is less than or equal to negative 1, and 2f of x plus b if x is greater than negative 1. Find the value of b for which this integral from negative 3 to 4 of h of x is equal to 32.8. Okay, so let's go ahead and do this then. We have the integral from negative 3 to 4 of h of x. We'll need to split it up as the integral from negative 3 to negative 1 of r of x dx, and then plus the integral from negative 1 to 4 of this 2f of x, 2f of x plus b. Okay, and we want this whole thing to equal 32.8. All right, well, this integral we know, okay, the integral from negative 3 to negative 1 of r of x is 28.8. 28.8. So we're going to subtract that from both sides. And then we get on the right side, we just get 4. Okay, so we're actually looking for the value of b where this integral is equal to 4. Now, let's go ahead and do what we have. We have 2 times the integral from negative 1 to 4 of f of x, and then plus the integral from negative 1 to 4 of b. Okay, so I'm kind of out of space here. Didn't leave enough space for this. Now, the integral from negative 1 to 4 of f of x, we've already done that. Okay, that was this thing right here. That was negative 8. Okay, so this is 2 times negative 8. I'm just going to come down here. I'm sorry that it's coming into the next part. 2 times negative 8, and then plus. Now, the integral from negative 1 to 4 of a constant is just the length of the interval times the constant. The length of this interval is 5, so this is just 5b. Okay, there's a negative 16. We add the 16 over, and we get 5b equals 20. Therefore, b must equal 4. All right. Finally, part E. Let me go ahead and move this out of the way now. We'll put it right there. Okay, this came there. All right. Find the limit as x approaches negative 1 of f of x over r of x, if it exists, and show the work that leads to your conclusion. Well, as x approaches negative 1, first of all, notice that f of x is approaching 0. Okay, so the numerator is approaching 0. Let me write that. Limit as x approaches negative 1 of f of x is equal to 0. Let's see what we can do with r of x. So the limit as x approaches, sorry, that's a negative 1, negative 1 of r of x equals, well, r of x is this big ugly thing. Let's go ahead and plug that in, shall we? We've got 1/3 times negative 1 to the 4 minus 3 times negative 1 cubed minus 3 times negative 1 squared minus 3 times negative 1, minus 4. What is this? This is 1 plus 3, which is 4, minus 3, which is 1, plus 3, which is 4, minus 4, which is 0, times 1/3, which is 0. Okay, so both numerator and denominator approach 0, which means we can use L'Hopital's rule. So the limit as x approaches negative 1 of f of x over r of x will equal the limit as x approaches negative 1 of f prime of x over r prime of x. Well, I'm going to go ahead and say this is equal to f prime of x at negative 1. That's just the slope here. Okay, that's the slope of negative 2. So I can say that's a negative 2 on top. But then the denominator, that's r prime. We're going to have to find the derivative of that big old function. So we have, and of course it's not in the same spot. Let's write the derivative and then I'll move it down. So we've got our 1/3. And then I've got the derivative here is 4x cubed minus 9x squared minus 6x minus 3. Okay, there's my derivative. That's r squared. Let's move it. All the way down. There it is. Okay. Let's go ahead and plug negative 1 into this, shall we? I'm really hoping this just works out. Plug in negative 1. 4 times negative 1 cubed minus 9 times negative 1 squared minus 6 times negative 1 minus 3. Whew. All right. In the denominator, we have negative 4 minus 9 is negative 13. Plus 6 is negative 7. Minus 3 is negative 10. Negative 10. All right. So let's flip the 1/3 up and get negative 6 over negative 10, which is 3/5. So there's our limit.